All right, so thank you to the organizers, to Neo4j, for inviting me to Keynote in what should be a fantastic conference. So I will be taking you on a very rapid tour through what I think are the most interesting developments in generative AI. And I'll be informed by my work as an advisor and investor in many leading companies, as well as my perch as a program chair in several leading industry conferences, past and present. So let's start with the foundation models, the large language models that we all have come to love and use. So I checked early this morning, and by my count, if I count all model versions and variants, I have very easy and cheap access to over 30 models. But truthfully, I probably only use models from OpenAI, Anthropic, Gemini, and Llama, but that's still a lot of models. So what can we expect from the people who are building these foundation models? So when I speak to the model builders or I listen to them give talks, it's clear that their North Star is still model size. So they're guided by what are called the scaling laws. So this basically say that as you increase the model size, the amount of data and the amount of compute, the models get better, and they get better in a predictable way. So what's the implication? The implication is that the models that are big now are going to get bigger. So the models that cost 100 million now are going to get even more expensive to train, at least the cutting edge models. And so the model providers actually generate quite a bit of revenue, and the revenue growth is actually very, very impressive. But the cost of training these models is also, as I pointed out, very expensive. And also, the models themselves are not sufficiently differentiated from each other. So in other words, if OpenAI has an outage, as long as you design your application properly, you're probably fine because you can switch to a Llama model or Claude or Gemini. So it's going to be very hard for this model providers to actually raise prices, right? Because there's too much alternatives for developers. So at least for the startups building these models, they're going to have to continue to raise money at ever-rising valuations. And so that's going to be problematic, could be potentially problematic given that the competition is fierce, right? So you can't really raise prices. So I started out with a bit of a downer. Now let's turn to some positive signs. Let's look at adoption. So earlier this year, we did a survey focused on healthcare professionals about their usage of generative AI. So we asked them about budget plans for this year. And this was early this year. So we found over a third said they would double their budget for generative AI, and close to half said they would increase it by at least 50%. And one of the things I look at regularly are job postings. And when I look at job postings in the US for generative AI related jobs, I see a lot of different applications. Obviously, content creation is where a lot of startups and a lot of early usage has been focused. But for us who are coding and programming, the use of these models as co-pilots for programming is just taken off, right? So I don't know any developer who doesn't really use a co-pilot at this point. And later on in this talk, I'll focus on one area that I'm fascinated with, which is the use of these foundation models in analytics and BI. So going to our survey from early this year of healthcare professionals, we found a wide variety of use cases. So in this graphic, I highlight two buckets. So in light blue, these are kind of use cases that pertain to interaction. So answering patient questions, chatbots, machine translation. And in maroon, you have use cases that in the past you would associate with NLP libraries. So things like summarization or information extraction or transcription. All right, so we know a lot of people are using it, but I also want to point out some of the main challenges that AI teams are facing. So early this year, a friend of mine and I wrote this post about, basically we were comparing the hype cycle for big data and generative AI. And I have to say, I think I've changed my mind on this. I don't think we've quite reached the peak of the hype cycle. And the reason I say that is I think that we've barely really scratched the surface in terms of what these technologies can do. So I think there's many more applications that will be kind of eye-opening moving forward. So one of the things that I noticed early this year, there were a lot of reports and surveys about the use of generative AI. And buried in these reports are questions about, what are some of the bottlenecks and what are some of the challenges. So I looked through a bunch of these surveys and I wrote a post, which you can Google, and the title is Why Your Generative AI Projects Are Failing. But in this talk, I'll try to at least briefly touch on two main areas, which are the data challenges and infrastructure and scaling challenges. All right, so let's look quickly at some early usage patterns for foundation models. So again, going back to our survey from early this year of healthcare professionals, we found that actually close to half use more than one model. And I think that if we were to revisit the same respondents now, this percentage would be higher because this was early in this year. So today, for example, Claude has gotten a lot better. Meta Llama family models have gotten better, and so has Gemini. So early in the year, probably GPT was still slightly ahead of these other families of models. So one thing that I think that teams should really kind of optimize for is post-training. So as I mentioned, so training foundation models from scratch is going to be very expensive. So I don't think a lot of us will be doing that. But on the other hand, a lot of us will take those base models and refine them, fine-tune them, use reinforcement learning with human feedback, or optimize them for deployment by using quantization, distillation, or pruning. And so I think that you and your team should really put yourself in a position where you can excel in post-training, because I really, truly believe this is where your competitive advantage will lie. So we have an abundance of models, right? So not only do we have so many base foundation models, with easy access to fine-tuning tools, we can fine-tune many custom models. So how should we use these models? So one way to use them is to use them in parallel, in ensembles, right? So I think the people who are familiar with machine learning are already familiar with ensembles. So there's an interesting twist for ensembles in the world of large language models, because you can imagine taking a prompt, passing it through multiple large language models, and even having them discuss among themselves. Or alternatively, using an open source tool like LLM Blender and get a blended or aggregate result. Another common pattern is what I'm calling cascades. And this is particularly common in model-based evaluation. So a typical usage pattern is as follows. You have an LLM, you generate an answer using your main LLM, and then you have a second completely different LLM which will act as a challenger or validator, right? So, and obviously you can have more than one LLM as a validator as well. Routers are essentially classifiers. So basically you have a prompt, your input, and the router will basically choose the most suitable LLM to send it to. And so I would say that last year routers were a bit of an advanced topic. But now we have open source projects like Root LLM or services like Unify.ai that make routing very accessible. And in fact, Unify will allow you to develop a router based on whatever criteria you want, right? So cost, latency, accuracy, or combinations of them. I think the most advanced topic in this area is model merging. And this really applies when you have models that have similar architecture and you have access to those architectures. So imagine a translation model, two translation models, right? So each good at translating certain languages, and then you merge them together, and then suddenly you have now a more capable model that can translate many more languages. So there are open source tools like MergeKit, but I would say this is still somewhat of an advanced topic. All right, so let's turn to data for generative AI. So I think many of us have read all these headlines about how the foundation model providers are worried that they're running out of data because they scraped all of the data already from the public internet. But as far as data, I think, number one, I really encourage teams to make a distinction between the types of data you need, right? So there's data for training, and if you're not going to do training from scratch, which most of us won't, you probably won't need to concern yourself with training data. But most of us will be doing fine-tuning. So you need to really make sure you have the data tools to gather fine-tuning data sets and efficiently, right? So fine-tuning data sets are basically labeled pairs of prompt and a desired response. And I'll go over what I mean by data for the application phase later in this presentation. So just because we're in an era of extremely large models doesn't mean that data quality doesn't matter, right? So data quality clearly matters if you're fine-tuning, right? So your fine-tuning data set should be of high quality. But actually, it turns out even the foundation model providers care a lot about data quality. So for example, Mistral, when they first released their first model, I remember reading the blog post, and they really devoted a lot of time in the blog post explaining how much they devoted to making sure that the pre-training data was of high quality. And this is where graphs can play a role. So here's an example for my friends at Visual Layer, right? So Visual Layer deals with computer vision data. So imagine billions of images or thousands upon thousands of hours of video. So what they have is a graph engine. So, and this graph engine allows them to build a user interface where domain experts can wade through this massive amounts of visual data and find, duplicates, blurry images or blurry segments in the video or mislabeled images. But all that is made possible because they are able to take this raw visual data and put it in a graph. And I think actually this approach will be very, very critical for all sorts of unstructured data that we need for generative AI. So synthetic data is obviously very promising, and I'm a big fan of synthetic data. One word of caution, synthetic data is a supplement, not a complete replacement, at least not yet, for your human-generated or organic data. So at this point, we're starting to see tools aimed at the data that we need for generative AI. So about 5 years ago, there was this wave of data engineering startups focused on building tools for building data pipelines and orchestrating these pipelines, managing these pipelines. But those tools, for the most part, were focused on structured data that was going to land in a data warehouse or data lakehouse. So I think we need similar tools for the unstructured data that we deal with in generative AI. And luckily, we're starting to see a set of startups and open source projects in this area. But we're still in the early days, and we'll probably still need more tools in this area. All right, so next I'm going to talk about retrieval augmented generation and its younger cousin, GraphRag. So the RAG community is very active, right? So there's RAG as a service now. So there's many companies that will let you basically do RAG as a turnkey solution. But I believe that most teams will probably still end up doing RAG on their own. And if you do that, there's now many resources that you can check out online where people have written up the results of their experiments. So these resources will give you tips and best practices. But if you read them closely, basically these tips and best practices are the result of experiments. Because RAG is a multi-factor undertaking, right? So you have to kind of experiment and run computationally intensive experiments at scale to basically optimize your RAG setup, right? So what is the right chunking strategy that I need to use? What indexing strategy? What's my search or retrieval strategy? What's my search re-ranking strategy? Or what embedding model should I use? Should I just use an embedding model from Hugging Face? Or like some teams I know of, develop a domain-specific embedding model. Speaking of embedding models, here's an interesting approach. So the way it works is as follows, right? So you take your corpus, you break it up into chunks of text. In traditional RAG, you will take those chunks of text and then embed them and land them in a vector database, right? So in this approach, you take each chunk, you run it through an LLM to get additional context around that chunk, and then it's the context plus the chunk that you embed. So Anthropic and a startup called Voyage AI have found that this is actually quite impactful when you do RAG. Of course, there's no free lunch. As you can imagine, this is very resource intensive and also will add to your costs because you have to compute a context for each individual chunk. So now let me briefly describe two very interesting examples of GraphRag. And I know there will be a lot of content about GraphRag in this conference. And kudos to Neo4j for really educating the developer community about the huge potential around GraphRag. The first example is from Google. And as best I can tell, it's not quite live. It's a blog post. But basically, what they've announced is they have a system that uses their data commons knowledge graph, which, by the way, is massive. It has 240 billion data points. And, with this knowledge graph, they created what can be described as a classic GraphRag system. And what I like about this is that once this is actually live, this might actually generate even more interest in GraphRag, because now you can compare the results of a plain LLM and the results of GraphRag. So another example that I just recently came across is from Metaphor. And Metaphor is a startup that's building tools for data governance, data discovery, and knowledge management. So what I find interesting about this example is they don't have a single knowledge graph. They have a hierarchy of 3 interconnected graphs. So they start out by using technical information, right? So what's your data? Where does it come from? What are the column names, the schema, data lineage, and all of that? Then they map that to business metrics and terms. So then that allows them to create a business graph. And then using information from their human resources systems and usage patterns of data, they create a social graph around how people are actually using the data, right? So who's collaborating with who's reading which report, who's using which table. So all three graphs are then used to power their GraphRag application, which, by the way, is live in production. Of course, not everyone has access to a knowledge graph. And again, kudos to Neo4j for building some initial tools to help people develop at least a starter knowledge graph automatically. But I think that one of the key lessons, at least to me, from GraphRag is structure really is helpful. So what I'm beginning to tell teams is, yes, we move towards GraphRag and start building your knowledge graph, but there might already be structure in your data that you can leverage. So one example that I came across recently is from Timescale. So they took issues from GitHub, right? So simple enough, and then they embedded those issues and landed it in a vector search index. And then they took those same issues and then they extracted as much metadata as they could. And then that metadata, they stored in a Postgres database. So then in their application, they blended the results of vector search and SQL. And then they found that this actually was much better than just plain RAG. So again, here you have structure in your data that you can take advantage of. Another potential direction for teams is an open source project called Sycamore. So imagine you have a bunch of documents, and inside those documents is actual structure, right? So a document can have a table of contents. It has chapters, sections, paragraphs, images, and tables. So that's what Sycamore takes advantage of. It takes that structure and forms a hierarchical data set around that structure. And the startup behind Sycamore, Aaron, has found that actually this hierarchical data structure is quite useful for retrieval augmented generation. All right, so now I'm going to give you a tour of some of the things I'm following closely in the world of generative AI. The first area is agents. Everyone is excited about agents. And this generation of agents, no surprise, are leveraging the foundation models we discussed. And this is more than robotic process automation. I don't know if you folks are familiar with the term RPA, but that describes automating repetitive tasks that tend to be describable using some kind of rule-based engine, right? So these agents, in this generation of agents, are more capable, right? So they can make decisions, they can take actions, and interact with their environment with minimal human intervention. Now, granted, I think the way to use these agents well right now is to make sure you're using them for rather narrow and well-defined tasks. To me, actually, the more interesting thing is at the end of the day, agents are software, pieces of software, right? So I'm interested to figure out what is the emerging software stack for building agents, right? So here's a view from Crew AI. So they're one of many open source projects. I listed some here in this graphic. And so what will be the emerging software stack for building agents? So what will be the components that we will come to rely on? So that's still up for grabs, and many people are putting forward their opinion on this. So at the end of the day, I think when it comes to RAG, GraphRag, and agents, it's really the access to this application data, the real-time data streams that will be really high impact, right? So, and many of these data, much of this data actually lives in structured data systems like Salesforce or your data warehouse or DoorDash or some service like UPS, right? But what you need to be able to do is use that data at the right time and present that to your AI system. It could be a RAG system, it could be an agent, right? So I'm actually surprised that not as many teams and startups have noticed or worked on this problem. I think too many people, frankly, are focused on unstructured text. But fortunately, my friends at Snow Leopard are working hard on this problem, and they'll have more to say in a month or so. All right, so to understand what's going on in generative AI, let me dive into two completely different personas. So the first one is analysts, right? So I looked at job postings for analysts that touch upon large language models, right? So that mention large language models. And what I found is actually analysts are using LLMs throughout their workflow, right? So from the initial ideation phase to researching, the information retrieval phase, to the analysis, all the way to generating the reports, right? So now analysts have tools to automatically generate charts using text prompts, right? So yeah, so as far as analysts, I think analysts will, at least in the short term, be mainly focused probably on fine-tuning data sets and building custom models to improve their work. And the rest of their workflow is can be semi-automated at this point. So math and mathematicians. So the reason that the foundation model providers are very interested in math is a great testing ground for their models. So if their models can solve complex math problems, that means that's a good sign that their models are improving their reasoning and problem-solving abilities. So today, I think mathematicians are using these large language models, but mostly as assistants, right? So just kind of aids in terms of writing and ideation, but I don't think these models can actually prove theorems or do actual professional mathematics at this point. But one area where I think is particularly interesting is that mathematicians use these pieces of software called theorem assistants and theorem provers, but like Lean. But the thing about these systems is they actually use a programming language. So one area where generative AI actually shines is translation. So now mathematicians can describe something in English or mathematics, and then generative AI can then translate that into the programming language that their proof assistant can understand. So let me focus a little bit on infrastructure. So one thing I've noticed is that actually a lot of tech-forward companies are building AI platforms, which at first struck me as odd because there's so many AI platforms that are available, right, in the cloud, or maybe even you can bring them on-prem. So I started reading their blog posts, watching their conference presentations, and I even spoke to some of the teams to better understand what is the decision-making process in terms of going the custom AI platform. And so I compiled the list, right? So based on all my research, right? So, so what they say is, they have unique needs and they want to have some flexibility and some ability to customize. And they also feel it gives them a competitive advantage, right? And then the other thing is that, if once they start using these things at scale, it's actually not cheap, right? So anyone who's used cloud computing platforms knows that at a certain scale, they become expensive. And then the other thing that stood out is many of these companies, their teams are already used to doing things a certain way with certain tools. So they have certain workflows and pipelines and tooling. And many of these commercial AI platforms don't really accommodate for that, right? So they want to be able to make sure that their teams can keep doing what they're doing. So the other thing that I notice is that many of the people who've gone the custom AI platform route have chosen Ray as the foundational layer for their platforms. So if you're not familiar, Ray is an open source distributed computing framework that has become kind of like the de facto AI compute engine for many companies who are building custom platforms. So in this graphic, I just kind of listed a few of them. So you can see many of them are in the, tech category. But the reasons for building custom platforms and choosing Ray are wide, right? So for example, Apple is concerned about GPU management. Pinterest and Netflix are concerned about large-scale data processing and model training. So there's many things to follow in the world of models, and I'm going to focus on only two of them in the interest of time. One is multimodality. And as many of you know, the models we have come to love and use are increasingly going multimodal. So now they not only can ingest and produce text, they can do images, maybe even sound for some models. Some models can produce video. But actually, I'm also interested in a very specific aspect of this called multimodal understanding. So I'm kind of tracking the progress in research in this area. So to explain this, I'll give you a very concrete example. Imagine a model that can watch hours upon hours of video and really understand what's happening inside that video to the point where you can actually quiz it and really interact with it, right? So this is more than what we have today, which is basically, most of these models cannot really watch video. They can maybe read the transcript, and based on the transcript, they can answer your questions. But really, there's a lot of things that happen in video, in motion, that are lost in the transcript, right? So, yeah, so I'm really kind of waiting for this area to really become much more practical and widely available. I'm particularly bullish on the open ecosystem for foundation models. I believe that these open weights models are going to stay competitive. As I mentioned, I think there's not a lot of real differentiation between all these really large models. So if I were you, I would focus on developing my chops for post-training these open weights models, because basically the ecosystem for these models is just so active. So many people are contributing and so many tools are coming online. So I think post-training, again, to repeat, is where your competitive advantage lies. I'm tracking the open source library VLLM. If you're not familiar with VLLM, its stated goal is to become the best open source library for inference and serving of large language models and foundation models. In fact, at the recent Ray Summit, there was a whole track focused just on VLLM. And in that track, many companies talked about how they were using VLLM at massive scale. And I believe there was even a talk by Roblox where they talked about how they were using VLLM to serve multimodal models. So on the hardware front, NVIDIA's lead in hardware is, I guess, a lot of it has to do with their software stack, CUDA. And one of the things I'm tracking is, are the other hardware providers keeping up with CUDA on the software front? And I'm keeping my fingers crossed, but at least I've come across now several startups that are very happy with AMD and AMD's ROCm software stack. So they use AMD and ROCm not just for training, but also inference. And so I think keep your eye out for ROCm and how many companies are beginning to use AMD. And there's also a lot of excitement about an open source project out of OpenAI called Triton, which also has a lot of contributors. But the bottom line here is that as these other software stacks mature, we'll have access to more hardware, which is good news for all of us. So we're in an interesting kind of phase because since the foundation models are so prevalent and so easy to use, it's gotten easier to actually build an interesting working AI application from scratch, right? So maybe now it might take you a few days to a week to build a really interesting RAG application or generative AI application. But then it might take you weeks upon weeks to evaluate it, to make sure that it's safe, that it's not hallucinating, and all of this. So I always felt that there was like this imbalance between all these tools for building applications as opposed to actually evaluating them. But now I'm starting to feel better because there's more and more open source projects for eval, for observability, and for monitoring. And in this graphic, I listed a few of them. So I'm not overly concerned about existential risks for AI. So I'm not a doomer, at least not yet. But I am concerned that I don't think enough teams are taking seriously risk management and risk mitigation. Because I cannot tell you how many teams there are that actually even have an incident response plan, right? So I don't know if many teams actually even have sat down and kind of decided or kind of met and kind of come to an agreement as to what an incident would be, right? Let alone having an actual concrete incident response plan. I think one of the challenges in this area of risk mitigation and risk management is that the tooling is quite fragmented, right? So there's tools for bias, but those are different for tools for checking copyright or disinformation, or tools for privacy and security. So you have fragmentation in the tooling. But the other thing is that actually we're also in a phase where we need people to collaborate across teams, cross-functional teams. So not only are the technical teams obviously need to be involved, but you have product teams and marketing teams. And most importantly for AI, legal and compliance, right? So right now, there's really no way for these different teams to collaborate if they're serious about managing risk for AI. And I tell you, I think most teams who are actually doing risk management for AI, the tools they use are quite laughable, basically Google Docs and Google Sheets. That's why I'm super excited about what Luminous.ai is building and proposing. So they're proposing a unified platform, or they're building a unified platform that will allow teams, cross-functional teams, legal, technical, product, marketing, to collaborate and have consistent workflows, consistent terminology and reports for managing AI risks. So the end result here is that everyone will have a unified view, and also this will allow you to kind of move more quickly and more efficiently. Because a lot of this, having disparate tools and having tools that really slow down collaboration, really slow down your ability to release your application as well. So, as you can tell, I'm fascinated by the larger question to me is how can we improve how we actually build these models that involve generative AI, right? So, because these applications, these applications that involve these large language models are very different from other pieces of software we built before, right? So, how can we be more disciplined and more systematic in terms of how we build generative AI applications, including agents? So one open source project that caught my eye recently that a bunch of technical teams that I know are using and teams that I respect are using is BAML. So think of BAML as an open source programming language. And basically the goal of BAML is to inject software engineering rigor, right? So that kind of rigor that we've gotten used to when we're building traditional software. How can we inject software engineering rigor into how we build generative AI applications? All right, so I said a lot. Let me now try to assemble these pieces together and give you some concrete takeaways. The first is design for flexibility. It's, make sure that whatever application you build, you're not tied to one model provider, so that you can easily switch model providers as you need to. And also, it's likely that you're actually going to use more than one model, right? So you're going to have all these systems that might involve routers or ensembles. And also the other thing, as I've been emphasizing, make sure you have the platform and infrastructure so you can excel at post-training. Because really, very few of us are going to be training models from scratch. The name of the game, the competitive advantage, is who's going to be good at post-training. And what is your data strategy for generative AI, right? So going beyond just vector databases or vector search, right? So what is your overall data strategy for working with massive amounts of unstructured data? So I propose that graphs might be play a role, especially when it comes to helping you improve the data quality of your unstructured data. In this world, scale matters, right? As I have noted throughout this presentation, you will need to run computationally intensive experiments at scale in order to optimize your RAG setup, your model, and your application. Take risk management seriously. Do you have an AI incident response plan? And finally, you will need to leverage AI to manage your AI infrastructure. Automation is going to be the key to overseeing your AI stack. And in keeping with the theme of the conference, graphs will be important moving forward. I think that Neo4j has done a great job laying the foundation for all of us in terms of graph RAG, in terms of getting the developer community excited about the potential of graph RAG. But I really believe we're just scratching the surface. And 2025 will be a huge year for graph RAG and graphs. And as I said, again, don't forget graphs will play a role in improving the quality of your unstructured data. That's all I have. Thank you for listening. And if you want to follow my work, subscribe to my newsletter, gradientflow.substack.com, and to my podcast, thedataexchange.media. Thank you, and enjoy Nodes 2024.